4.3.1 Simple harmonic motion. This is another homework problem. We're going to look at number 3. The following table gives the average population in thousands of a southern town for each month throughout the year. The population is greater in the winter and smaller in the summer and repeats this pattern from year to year. Find a sinusoidal function to represent the population of the data by hand and make a scatter plot of the data. So you're just going to take these points. Remember, January we know starts with the first month, and February 2, and you keep going all the way up to December, which would be 12. So you're going to take those values and graph them. So we know that the months is for our x, and the population in thousand would be your y. So rather than do this by hand, which you guys are going to do, I did it in the calculator because it's hard for me to do on the screen here. So here is a scatter plot of what our data looks like. Oops. And for this, let's go ahead and come up with our equation by hand for this. Remember, when you're coming with equation, that means you want to find your max and min values because that's going to help you find your amplitude and your midline. So it looks like here at 4.5, we have a minimum, and here at 10.9, we have a maximum. So to find my amplitude, remember it's equal to your maximum minus your minimum divided by 2. So you can do that on your calculator. So we have 10.9 minus 4.5, divide that by 2, and you would get 3.2. And the midline is, of course, your maximum plus your minimum divided by 2. So when you do that on your calculator, 10.9 plus 4.5 divided by 2, you get 7.7. And then the next part we need to come up with is figure out for a sinusoidal function, we need to figure out what the b value is, and if we have a phase shift, because recall we have y is equal to a times the sine or cosine. I'm going to do cosine. And then b times x minus c plus d. So we have our a and our d. We need to find our b and our c. Well, to find your b, recall that the frequency times the period is equal to 2 pi. So then that means if I want to figure out my b value, b would be equal to 2 pi divided by the period. So the period, of course, if we're talking about the months, there's 12 months in a year. So that tells me that the period is equal to 12. And then the b value would be 2 pi divided by 12, or pi over 6. So looking at my graph here, if I think about my midline, 7.7, be somewhere in here. So because my graph started at 3, so this would be where our midline's at. So it looks like, you can tell, and we know from June, the fact that June is the 6th month, it looks like that would be at a minimum point and this is a maximum. So I'm actually going to use that point right there to kind of help me write my equation because it looks a little bit easier. So one equation we could have would be y is equal to my amplitude, which is 3.2, but because it's starting down, I would use negative 3.2 times the cosine of my b value, which is pi over 6, times x minus, in this case, we're going to the month of June, so minus 6, and then plus 7.7. So that's just one possible equation. Of course, I could do another one using a phase shift of 1. If the period, of course, is 12, then divide that by 4, which means your key points are going by values of 3. So then you could figure out where your sine graph is by taking that 6 and subtracting the 3. So there's different ways you can figure out how to come up with your graph. So this would be my graph by hand. So then the next part says use your calculator to find a sinusoidal function to model this data. Then we're going to use the model to predict the times of year which the average population is 6,200, because remember this is populations in thousand. So when I use that to help myself, I'm not going to actually plug in 6,200. I would actually be plugging in 6.2. So going to my calculator, the first thing you want to do is plug this into your stat plot. So go to stat and hit enter on edit. So in list 1, you're going to put your months, so 1 to 12, and then in list 2, you're going to write down your population in thousands. After you do that, I like to look at the graph of this, so I would go to second y equals and turn your stat plot on by hitting enter and on. Make sure you're in list 1 and 2. Then if you go to zoom, and remember we have a zoom stat button, so if you hit zoom 9, remember that zoom 9 is actually going to give you this picture right here. So that's what my graph was, and that's what I had here. So then to write the equation from my calculator, we go to stat and right arrow over to calculate. And if we scroll down, notice we have our sine regression, so I can hit enter. Don't worry about that because not everyone has the iteration, so we're just going to go ahead and let's go ahead and store this equation into y1. So remember to do that, you go to vars, yvars, function y1. So that puts it in here. We're not going to worry about the period for right now because not everybody can do that in their calculator. If you have an older calculator, it doesn't actually let us put that in there. So we're going to leave that blank and then go to calculate and hit enter. So now I have the equation that my calculator comes up with. So I'm going to go ahead and write this on my paper. And remember, we talked about the fact when you're doing this in your calculator for the sine regression, it's going to give you a sine equation. It doesn't actually factor out that b value, and it also writes it slightly different because it doesn't factor out the b value. So in order to find our period, you could take your b value and divide it by 2 pi, and you could also factor that out to figure out what the phase shift is that they're using. So now that I have this, it says we want to use the model predicted times a year, which the average population is 6,200, or we're going to use 6.2. So this is already plugged into Y1. That's what we did when we plugged it into our YVAR. So in Y2, I'm going to plug in 6.2 and look at the intersection. So I want to go here. And remember, because we did the YVARs, it's already in my graph. So I want to try to make that as accurate as I possibly can, which is why I, instead of typing it in by hand, I did the YVARs. So again, just to do that, you go to stat, right over to calculate, go down to your sine regression, and then go into store regression equation to vars, yvars, function, and y1. If you have the older calculator, you do the same thing just next to that and hit enter. And that again puts it into your y equals. So now when you look at the graph, you can actually see the equation that your graph came up with. And then we can, of course, go ahead and start to figure out when y2, so in y2, I'm going to have to plug in 6.2 and hit graph. And I'm trying to look for the intersection for when that happens within 1 year. So second trace, we want the intersection. And I'm going to have to do this twice. So I want to go over to where the intersection is and close to it. And I'm going to hit enter 3 times. So it looks like 3.91. So 3.9 is late March. And then second trace. And I'm going to do the same thing. I want the intersection, except for now I'm going to have to use my right arrow to go to the other side. And hit enter 3 times. And we get 8.1, so early August. So those would be my 2 answers. So I'm going to write that down here. So we got 3.9, 6.2 for the point, and the other one was 8.1 was when we had 6.2 for our population. So again, this is late March and early August for that. So that would be my solution. Another important thing to mention when you're graphing these, again, make sure your mode is in radian mode, because if it's not in radian mode, you would get something different. We could also, of course, graph our equation to see how it compares to the one that we got with the calculator. So I'm going to go ahead and do that. I'm going to plug in negative 3.2 times the cosine of pi divided by 6 times x minus 6 plus 7.7. And hit graph. So this equation right now that's graphing is actually the one that the calculator got. My equation is going to be the next one. And you can see it's kind of graphing over it. And they essentially look pretty much the same, just slightly different because the calculator maybe rounded a little bit more. I could even go in here to my y equals and make that a little bit of a thicker line just to show you. If I hit graph, it'll graph the calculator one first because that's in y1, and then again this thicker line that's going to graph, you can now see it essentially looks very similar to the one that we got in the graphing calculator. It's just that again our graphing calculator doesn't use the factored out b value, so it's slightly different.